Good day to you, children. Without wasting any time, let us move to exercise 3.4 second main, where we have several situational problems, and out of which the first one is, if we add 1 to the numerator and subtract 1 from the denominator, a fraction reduces to 1. It becomes half. The second part of the question says, it becomes half if we only add 1 to the denominator. So what is that fraction? So to do this, first let the numerator be x and the denominator be y. So now the fraction is, how do you represent the fractions? Fractions are numerator upon denominator. So then the fraction is x divided by y. Alright, so now what they have told us, if we add 1 to the numerator, x plus 1, and we add 1 to the and subtract 1 from the denominator, y minus 1, then our fraction reduces to 1. Then the fraction is equal to 1. This will be reduced to our equation 1. So this implies x plus 1 is equal to 1 into y minus 1. So this implies x plus 1 is equal to y minus 1. This implies x minus y plus 2 is equal to 0. This is our equation 1. From the first situation, we got our first equation, that is x minus y plus 2 is equal to 0. And the second part of the question says, the fraction becomes half if we add 1 to the denominator, only adding 1 to the denominator. So x, no change in x, we are adding 1 to the denominator, that is y plus 1. Then our fraction becomes half. So cross multiplying, we get 2x is equal to y plus 1. Y plus 1, so transpose everything to the LHS, we'll get 2x minus y minus 1 is equal to 0. This is our second equation. Now using elimination method, let us find the values of x and y, and thereby finding the fraction. So here let us, if you can see, then y, the coefficients of y is same. The coefficient of y is minus 1 in both equations. Thus, subtract 1 and 2. Subtract 1 and 2 will eliminate the variable y, then we'll get the value of x. So since we are subtracting 1 and 2, let us write them down. X minus y plus 2 is equal to 0, and 2x minus y minus 1 is equal to 0. Since we are subtracting them, the signs will change at the bottom. Plus becomes minus, minus becomes plus, and once again minus becomes plus. So x minus 2x will get minus x. Minus y plus y cancels each other. Here I am not multiplying the coefficients because already the coefficients are same. So minus y plus y 0, and here plus 2 plus 1 plus 3 is equal to 0. So this implies minus x is equal to minus 3. Minus minus cancels each other. We'll get, therefore, x is equal to 3. So the value of the numerator of our fraction is 3. Now to find the denominator, put x equal to 3 in equation 1. In equation 1, let us put x equal to 3. We get, this implies 3 minus y plus 2 is equal to 0. This implies 3 plus 2, 5. So minus y plus 5 is equal to 0. This implies minus y is equal to minus 5. So this implies minus y cancels each other. Y is equal to 5. This is the value. So since we got our numerator and denominator, therefore our required fraction is 3/5. This is our required solution. So in the second problem of the second main from the same exercise, it is a age related question. So in the first exercise we had an age related question where we put a table and then thereby from there we constructed our equations. So here let us do the same. But first the question is, 5 years ago Noori was thrice as old as Sonu. 10 years later Noori will be twice as old as Sonu. How old are Noori and Sonu? So first let Noori's age be X and Sonu's age be Y. So now let us put our table X, Y, 5 years ago. 5 years, right? Yeah. 5 years ago, X years. The ages are X years and Y years. These are the present ages. So 5 years ago and 10 years later. We have two situations. 5 years ago, Noori's age would have been X minus 5. The same thing. Now in this year, if your age is 15, 5 years ago your age was 15 minus 5, that is 10 years. Similarly, Sonu's age would be Y minus 5. So 10 years later, Noori's age would be X plus 10, and 10 years later, Sonu's age would be Y plus 10. Same thing. If your age now is 15 years, then 10 years later, you will be 25 years old. So this is the table which we will be using for our constructing our equations. So what happened 5 years? 5 years ago, Noori was thrice as old as Sonu. That means X minus 5 is equal to, this is 5 years ago's Noori's age, right? So 5 years ago, Noori was 3 times older than Sonu's age at that time. So X minus 5 is equal to 3 of Y minus 5. On simplification, we get X minus 5 is equal to 3Y minus 15. So X minus 3Y plus 10 is equal to 0 is our very first equation. Similarly, taking the same arguments that we used in constructing the first equation, let us write Noori's age after 10 years is X plus 10, and she will be twice, 2 times as old as Sonu, whose age would be Y plus 10. So now simplifying and rearranging, we get X plus 10 is equal to 2Y plus 20. This implies X minus 2Y minus 10 is equal to 0. This is our second equation. If you take a look at both your equations, then you will find that the coefficients of X in both the equations is equal to 1. So since the coefficients are already equal, I am directly going to subtract the equations. If you want, you can make the coefficients of Y equal by cross multiplying the coefficients to each of the equations and cancel Y variable. There is no harm. So here, since coefficients of X in both equations is 1, let's subtract 1 and 2. The first equation is x minus 3y plus 10 is equal to 0, whereas the second equation is x minus 2y minus 10 is equal to 0. So since we are subtracting, the signs at the bottom will change, minus, plus, plus. So x minus x cancels each other. Minus 3y plus 2y, we get minus y, and plus 10 plus 10, 20 is equal to 0. So this implies y is equal to 20. So Sonu's age is 20 years. Now put this value of y in equation 2. Either of the equations, no need, there is no condition that you should always put it into. It depends which equation you want to choose. So here we get x minus 2 into 20, because it is x minus 2y. So x minus 2 into 20 minus 10 is equal to 0. So this implies x minus 2 into 20 minus 40 minus 10 is equal to 0. This implies x is equal to 50. So now let us write our result in proper sentences. Noori's age is 50 years and Sonu's age is 20 years. This is our required solution. Since I had given you the third question of the second main as homework in the last class, now I am going to solve the fourth question. That is, Meena went to a bank to withdraw rupees 2000. She asked the cashier to give her rupees 50 and rupees 100 notes only. Meena got 25 notes in all. Find how many notes of rupees 50 and rupees 100 she received. So first, let the number of rupees 50 notes be x and the number of rupees 100 notes be y. So the first part of the question says, she asked the cashier to give her 50 and 100 rupees notes only, and she withdrew exactly 2000 rupees. So that means she got 50x plus 100y is equal to total 2000 rupees. This is our first equation. We can reduce it. 50 ones are 52s are 50 40s are 50 40s are. So now the equation has been reduced to x plus 2y is equal to 40. Once again, we can name it as equation 1. Similarly, the second part of the question says she got 25 notes in total. That means the number of notes, 50 notes plus number of 100 notes, she got 25 notes. The total notes she got is 25. This is our second equation. Once again, using the elimination, we have to find the values of x and y, because the question is to find how many 50 rupee notes and how many 100 rupee notes Meena received. So here, if you look once again, the coefficients of x are same. So let us directly subtract the equations. Since coefficients of x are same in both equations, let's subtract them. We are going to eliminate x. So here write it down. X plus 2y is equal to 40. X plus y is equal to 25. Since we are subtracting, the signs at the bottom are changing. Minus, minus, minus. X minus x cancels out. 2y minus y. Y is equal to 40 minus 25. 10 minus 5, 5. 3 minus 2, 1. 15. So y is equal to 15. That means she received 1500 rupee notes. Now put this in equation 2. We have to find the number of 50 rupee notes. So x plus 15 is equal to 25. This implies x is equal to 25 minus 15, which is equal to 10. This implies x is equal to 10. So Meena received 10 50 rupee notes and 1500 rupee notes. It matches up. 15 into 100, 1500 rupees. 10 into 50, 500 rupees. 1500 plus 500. She withdrew 2000 rupees. Therefore, Meena got 10 rupees 50 notes and 15 rupees 100 notes. This is the required solution. Moving ahead to the last question of the exercise 3.4. A lending library means the library where you can borrow books. A lending library has a fixed charge for the first 3 days and an additional charge for each day thereafter. So if you are borrowing a book from the library, then for the first 3 days they have like some fixed amount of rupees, and if you exceed in the return, if you keep the book with yourself for more than 3 days, then they have additional fees for that. Sarita paid rupees 27 for a book kept for 7 days. So Sarita borrowed a book from this library and she kept it with herself for 7 days, but she paid 27 rupees for that, for how many days she had. While Susie paid rupees 21 for the book she kept for 5 days. Find the fixed charge and the charge for each extra day. So first let us write, let the fixed charge be x and the extra charge be y. So now for the first 3 days only the fixed charge is going to be applied for the books. So first Sarita kept the book for 7 days. So Sarita's situation. First let us algebraically represent Sarita's situation. She kept the book with herself for 7 days, where the first 3 days she had fixed charge, 3 fixed charge days and 4 additional charge days, right? Additional charges. So then our equation can be written as x plus 4y, and she totally paid rupees 27 to the library. This is equation 1. Here for the first 3 days the charge is fixed. That is why for x there is no coefficient. The coefficient is 1. So x is as it is. Similarly for Susie kept the book for 5 days. So she paid 3 days fixed charge. 3 days fixed charge. And 2 days additional charges. Right. So now the equation will be, now the new equation will be x plus 2y is equal to, the total amount she paid was 21 rupees. So these are our two linear equations in two variables. So now once again, if you see here, the coefficients of x are same. So let us subtract. Let's subtract 1 and 2. We get x plus 4y is equal to 27. X plus 2y is equal to 21. So since we are subtracting, the signs will change. X minus x cancels out. 4y minus 2y, we have 2y is equal to 27 minus 21 is 6. So y is equal to 6 by 2, 2 ones are 3s are. So y is equal to, this implies y is equal to rupees 3. So the additional charges for each day exceeding the 3-day limit is 3 rupees. And now to find the fixed charge, put y is equal to 3 in equation. Either of the equations, I am going to put it in equation 2. So we get x plus 2 into 3 because x plus 2y is equal to 21. So this implies x plus 6 is equal to 21. And this implies x is equal to 21 minus 6, that is 15. So x is rupees 15 for the first 3 days. The fixed charges is rupees 15, and if you exceed that limit, then each day you have to pay 3 rupees. So therefore the fixed charges is rupees 15 and additional charges is rupees 3 per day. So this is our required solution for the equation. This completes your exercise 3.4. In the next class, we'll be learning about, since the cross multiplication method has been deleted, we are going to skip from that concept and exercise 3.5. We are directly going to equations reducible to a pair of linear equations in 2 variables. There are and the last exercise of the chapter, which is exercise 3.6. That's all for today. Thank you.